In this example, we're asked to find the derivative of f of t equals the quantity 3t minus 1 to the fourth times the quantity 2t plus 1 to the negative 3. So I can immediately see that we're going to need the product rule here. And additionally, within the product rule, since these are essentially one function embedded inside of another, for instance, with the 3t minus 1 inside x to the fourth, we're going to need the chain rule as well. And of course, the chain rule reminds us to take the derivative of the outside function first. So f prime of the outside, leaving the inside alone, times the derivative of the inside. Okay, so let's do this all together here. Looking at this function, I'll treat this first bit here, 3t minus 1 to the fourth, as a, and the second bit as b, 2t plus 1 to the negative 3. Let's do this derivative. So f prime of t, okay, a prime b. So a prime is 4, leave the stuff inside alone, to the third. Okay, that's the power rule. Now what goes inside? Exactly what was in there before. 3t minus 1, we don't touch that at all. Now we hit it with the chain rule and take the derivative of the inside. Well, the derivative of 3t minus 1 is simply 3. All right. So there's a prime, and then we need b, so 2t plus 1 to the negative 3. Okay, so what have we done so far? We have a prime and b. Okay, so now we do the second part of the product rule, b prime a, so plus b prime, so now I'm taking the derivative of this b term here, so we have negative 3, stuff inside to the negative 4. What goes inside? Same thing that's in there already, 2t plus 1. But don't forget the chain rule, right? Here's our chain part. We have the times the derivative of the inside. The derivative of 2t plus 1 is simply is simply 2. So there's b prime, and now we multiply by a, 3t minus 1 to the fourth. All right, so what have we done here? This is our b prime and our a. Okay, so there we go. Believe it or not, the calculus is finished for this example. It's all algebra from here, and of course, algebra is the tricky part. To simplify this thing, we simply want to factor out the greatest common factor. So let's see what we're working with here. Let's just note first off that 4 times 3 is 12, and negative 3 times 2 is negative 6. So when I'm trying to decide what to factor out, I'll factor out, well, out of those two I can get a 6. That's not nothing. But we have all these other terms. When you're trying to figure out what to factor out, when you have more complicated terms like this, the one you factor out is whatever is further left on the number line. And I'm talking about the exponents here. So another way to think of it is factor out the one that's more negative. So we have 3 and 4 when we're looking at 3t minus 1. Well, 3 is further to the left on the number line, so I'm going to factor that out. 3t minus 1 cubed comes out. Similarly, we have 2t plus 1 to the negative 3 and 2t plus 1 to the negative 4. Well, negative 4 is further left on the number line, so that's the one I'm factoring out. 2t plus 1 to the negative 4. Let's pick up the pieces and see what's left behind. Well, we had a 12 in this term. We factored out a 6, so we get a 2. And then the entire 3t plus minus 1 came out to the front, leaving us here to deal with this 2t plus 1 to the negative 3. When you factor something out, and this is important, when you factor something out, you're actually dividing everything left behind by that term. So when we factored out this 2t minus 1 to the negative 4, what we're really doing is dividing all these terms left behind by it. So if I divided this term by 2t minus 1 to the negative 4, I would have a negative 4 exponent here, and then we would subtract the exponents. So what we'd be really doing is, looking at the exponents, we'd have minus 3 minus a negative 4 when we divided this out and factored this out. Well, negative 3 minus a negative 4 is a positive 1, and this is the cool thing about this kind of factoring. When you just factor out the most negative term, look what happens. We have left over 2t plus 1, well, to the 1, which is just 2t plus 1. So that trick that I did just then is pretty important, and it's a very subtle trick, but it's some really cool algebra that helps you simplify these super complicated expressions that you get after applying the product rule and the chain rule. Okay, moving on to our next term. So now we're over here. Well, we factored out a negative 6, but we factored out a positive 6. We still have a negative 1 left behind. This entire 2t plus 1 to the 4th came out to the front, so that's gone. And now we have 3t minus 1, but we factored out 3 of these. That leaves us with 4 minus 3, which is one of them, because remember, when we factor something out to the front, we're actually dividing all the terms, so we subtract exponents. So this leaves us with 3t minus 1 to the 4 minus 3, which is 1. There we go. And now we're on a roll. So here I'm just going to simplify this inside bit here before I rewrite the whole thing. Distributing the 2 gives us 4t plus 2 minus 3t plus 1. Combining like terms there gives us t plus 3. So this whole bit inside these parentheses here factors to t plus 3. Thus, we can rewrite our final answer here as 6 times 3t minus 1 cubed times 2t plus 1 to the negative 4 times t plus 3. So some really fancy algebra was required to arrive at that very nice condensed form, but it's algebra we should be able to do, at least with enough practice. And since the original exercise gave us a negative exponent, I'll present the answer with a negative exponent, so you don't necessarily have to take that down to the denominator. So there you go. Practice this technique. It's the kind of thing you see again and again in calculus.